Okay, welcome to our discussion of pH. This can get a little weird because of what pH actually is, so let's define that first. pH is the negative log of the concentration of H+. So you're going to have to be able to do logarithms here. Now, we're not going to have to go into the theory behind logarithms, we're just going to have to know how to do them on our calculator. We're going to use this tool. So the first thing we need to define is, well, what does our scale tell us? Well, from 0 to 7, we say it's an acid. From 7 to 14, we say it's a base, but if it's exactly 7, we call that neutral. Now, the pH scale was designed to measure a specific range of concentration of H+, all right? Just like your bathroom scale is not designed to get the weight of a circus elephant or the weight of a single feather. It's designed for a given range of weights, just like the pH scale, all right? So let's talk about neutral first, because everything, the whole scale is based on water. So water has a pH of 7. Well, if it's got a pH of 7, and we know the formula for pH, that means 7 equals the negative log of the concentration of H+. Now when we solve this, what that means is the concentration of H+ is 10 to the negative 7th molar. So there are H+ ions that are in pure water. But now we have to ask ourselves, what does neutral mean? And if we're thinking about charges, that means we have the same amount of positive as we do negative. They cancel each other out, they're neutral. What is related to this, as in our previous video we talked about what acids and bases are, the positive is the H+ and the negative is the OH-. So we need the same amounts of those. So this means that H+ equals OH-. They have the same concentration. If the concentration of H+ is 10 to the negative 7, that means the concentration of OH- has to be 10 to the negative 7. There's another scale that is not really known, and that's the pOH scale, all right? It's found the same way pH is, and so here our pOH is 7, which leads us right into this statement right here. And notice I wrote always here. The concentration of H+ times the concentration of OH- always equals 10 to the negative 14. That's something that happens in nature. Or we can write this a different way. The pH plus the pOH equals 14. If we step back over here, 10 to the negative 7th times 10 to the negative 7th gives us 10 to the negative 14th. Or 7 plus 7 gives us 14. Both of those are equivalent. It doesn't matter to me which one you use. I tend to use this one just because the math can happen real quick. Okay, this is an extremely important thing right here, all right? We need to make sure that we understand this guy, all right? Because that is gonna dictate what we are doing. If we have a strong acid, and if you remember the list of strong acids from class, hydrochloric acid, nitric acid, sulfuric acid, the concentration of the strong acid is equivalent to the concentration of H+. Just as for a strong base, like sodium hydroxide, potassium hydroxide, any soluble hydroxide compound, the concentration of the strong base equals the concentration of OH-. All right? So now that we understand that, let's go through and make sure that we write out a chemical equation so we can kind of wrap our heads around it. If we talk about hydrochloric acid, its concentration is 0.01 molar, right here. But we know that hydrochloric acid is a strong electrolyte, so it completely breaks up in water. When it does so, it generates H+ and Cl-. If the our ratio here is 1 to 1, which means if the concentration of HCl is 0.01 molar, then the concentration of H+ has to be 0.01 molar. If the concentration of H+ is 0.01 molar, our pH is 2. Now let's talk about hydroxide, because there's still some of that around. If H+ is 0.01, hydroxide's 10 to the negative 12th, which has a pOH of 12. Again, 10 to the negative 2nd times 10 to the negative 12 gives us 10 to the negative 14th, or 2 plus 12 gives us 14. Here, sodium hydroxide. By the way, these are the two most common things, most common acid and most common base. If that has a concentration of 0.01, it's a strong electrolyte. If you remember the solubility rules, we know that all sodium compounds are going to be soluble. We get Na+ and OH-, all right? 1 to 1 ratio, meaning that our concentration of OH- is also 0.01, which gives us a pOH of 2. If pOH is 2, we know pH is 12, and our concentration of H plus is 10 to the negative 12. All right? So now that we're done with this, let's really define what an acid and a base are. All right? An acid is something that has a concentration of H plus that is greater than 10 to the negative 7. That's an important thing to understand. If we talk about an acid, concentration greater than 10 to the negative 7. If we have a base, that concentration of H plus is less than 10 to the negative 7. We can talk about the concentration of OH minus as well, but let's stick with H plus since the pH scale is something that is looked at more regularly than the pOH scale.